Hello ladies and gentlemen, and thank you for clicking on my presentation of scales. So let me break it down to the simple question: what is a scale? The simple definition is one of many small plate-like dermal epidermal structures that characteristically form the external coverings of fishes, reptiles, and certain animals. Oops. So let's dive more into this definition and find out more about it. It's a very broad topic, so I'm going to go and try to fit as much as I can in this small presentation. So let me begin with fish scales. Why do fish have scales? Fish scales mainly protect the fish from its environment. They overlap like shingles on a roof so that the skin of the fish is not exposed. Most fishes get extra protection from a layer of slime that covers their scales. This slime helps them move through the water better and keeps pests off the fish skin. Let's talk about the different types of scales. Different types of scales are placoid scales, cosmoid scales, ganoid scales, and stenoid scales, and cycloid scales. Placoid scales are mainly found on sharks and stingrays, and they're tough scales that covers the whole skin. They are packed tightly together and grow with their tips facing backwards. This gives the fish's skin a rough feel, and they're very microscopic. Placoid scales stop growing after they reach a certain size, and then more scales are added as a fish grows. Cosmoid scales are found in several ancient fishes, including some of the earliest lungfishes, and were probably derived from the fusion of placoid scales. Ganoid scales are very similar to cosmoid scales. Then we come to the next two, which are stenoid scales and cycloid scales, which are common in the fish we see today. Stenoid scales have a toothed outer edge and are usually found on fish with spiny fin rays, such as the bass. And then cycloid scales have a smooth outer edge and are most common in fish with soft fin rays, such as the salmon and carp. Then we could go on to counter shading. Counter shading, many fish are dark on top and light on bottom. When seen from above, they disappear by bleeding in with the dark color of the depths of the bottom, and when seen from below, the light belly blends into the sky above. Okay, and let's move on to why do fish scales shine? It's due to the sophisticated system of crystals that enhance light reflection and may help fish hide from predators in the wild. Scientists have known for years that guanine crystals in the skin underneath the scales of fish reflect light to produce a mirror-like sheen. This silvery reflectant acts as a form of camouflage that helps protect fish from predators as fish swim near water's surface. Okay, and then we'll quickly move on to reptiles, snakes. Snake scales are dry and not slimy, unlike fish. Snakes do not cover their body with mucus. Snake scales are made of keratin, just like our hair and fingernails. Snakes do not get more scales as it grows. The scales just get larger. The scales are transparent. All colors except blue and green are formed on the inner layer of the skin, and not the scale itself. Blue is created by a crystalline substance in the scale surface which diffracts light. Green is created by combining blue with yellow on the inner layer. These crystals also cause beautiful iridescence, especially in snakes with smooth scales. Then we have keeled scales. Keeled scales scatter light differently when compared to smooth, flat scales. As a result, more reptiles with keeled scales are not shiny. They have dull, non-reflective appearance. It is therefore possible that keeled scales further improve the camouflage effect already provided by the skin coloration, shading, and disruptive patterns. And then we'll move on to other reptiles, scute scales. And scute scales are similar to scales and serve the same function. Unlike scales of lizards and snakes, which are formed from the epidermis, scutes are formed from lower vascular layer of the skin, and the epidermal element is only in the top surface, forming in the living dermis. The scutes produce a horny outer layer that is superficially similar to that of the scales. And it's scute scales are mainly derived of keratin, same as our hair and nails. And in turtles and tortoises, the entire carapace of the upper shell is a structure of fused scutes. The scutes running down the center of the shell along the spine are called central scutes. The next row of scutes on the either side of the spine are called costal scutes. The outer scutes are known as marginal scutes. And the plastron of the underside of the turtle shell is also made up of scutes. That would be it for my time for this presentation, so I'll just leave you with some paintings of scales, beautifully done. As you can see, the most successful ones are the ones that show the scales mainly in the light, and then the rest will just fade away, and this gives it a nice rendering effect and a realistic feel. Okay, and that would end my presentation. Thank you. Have a good day.